Hello everyone. Let's begin the chapter of mathematical reasoning or mathematical logic. In about 1623 AD, the famous Italian astronomer Galileo Galilei once wrote in one of his published papers that the universe cannot be read until we have learned the language and get familiar with the characters in which it is written. It is written in mathematical language. So, he called mathematics as a language at that time, and after that several other scientists like Gibbs and Einstein also denoted mathematics as a language. Okay? We all know that mathematics is a tool that is used in almost every field to solve various problems. The problems in science, the problems in commerce, the problems in everywhere in the world can be solved with the language of mathematics or with the help of the tools provided by mathematics. And the language of mathematics also gives us the power to question anything, to understand any concept by the help of reasoning or by the help of logical thinking. Here comes the necessity and the requirement for the chapter of mathematical reasoning or mathematical logic, as without reasoning or without logically asking any question, one cannot survive in the real world. So let us start the chapter of mathematical reasoning or mathematical logic. First of all, we shall understand some basic terminologies related to the mathematical reasoning or mathematical logic chapter. Okay? So as you can see here, we will begin with the concept of sentences. You all are very much familiar with the term sentence. From your very childhood you have read in the subject of English that what a sentence is. A sentence is a group of words or a collection of words that convey some meaning. When you are trying to convey your message to another person, you generally form a sentence, a meaningful sentence, and try to convey that message to the other person, right? We all should know that there are various kinds of sentences present. Okay? In English language also, we know that there are various sentences like the assertive sentence, the imperative sentence, the exclamatory sentence, the interrogative sentence. Okay? These are all different kinds of sentences. Okay? So what are assertive sentence? An assertive sentence is a declarative sentence by which we generally declare something or state something. Okay. So it is also known as a statement. The imperative sentence is all about putting a request for something. Means any sentence that represents some request is imperative sentence. And exclamatory sentence is a type of sentence which is used to represent any feelings or to convey the message of with some feelings, okay, some strong feeling. And interrogative sentence generally refers to those type of sentences in which we ask some questions. Okay, so these are the type of sentences we generally encounter, but here we will only focus on the assertive or the declarative sentence, which forms the base for our discussion in mathematical reasoning or mathematical logic chapter. So we see here that statement or proposition is a kind of assertive sentence. Okay, and what is a statement or what is a proposition? So statements or propositions are elementary atomic sentences that may either be true or false. That is, they convey a message which is either true or false in nature. Okay, and these are known as propositions. Okay, there are mainly two types of propositions. One is known as atomic proposition, atomic also known as simple. Atomic means simple. Atomic proposition, and another is compound proposition. Okay, so one is atomic proposition and another one is compound proposition. So what are atomic propositions? An atomic proposition or a simple proposition or just an atom is a symbol that generally starts with a lowercase letter and it may be either true or false. Okay, a compound proposition are generally formed from the atomic proposition using various connectives like and, or, not, if, then, if and only if, this kind of connectives. Okay, so an example of an atomic proposition is a simple statement, say it is too hot. Okay, so this is an example of an atomic proposition. Okay, and a compound proposition, it is too hot and the wind is blowing. Okay, so these are some of the examples of atomic proposition and compound proposition. Okay, so we will now move into different type of statements and different reasoning concepts by which we can start our reasoning journey. Okay, now take a note of the various logical connectives, and these are some of the symbols used to denote those logical connectives which are used to form our compound sentences. Okay, so take a note of these symbols. This symbol is used for not or negation. This one, similar to that of the intersection symbol in our set theory, it's also used for and or conjunction. This symbol, which is similar to the union symbol of our set theory, it is used for or disjunction. Okay, and this symbol is used for if then kind of statements or implication statements, and this symbol is used for if and only if type of statements, or those are known as double implication statements. Okay, so these symbols will be used thoroughly in case of our study of mathematical reasoning or mathematical logic. Okay, so these are the various syntax for writing the statements with the symbols. Okay, so this denotes the negation of the statement P, and if P and Q are two unique statements, then this denotes the conjunction of P and Q, this the disjunction of P and Q, this denotes implication of Q from the statement P, and this denotes P is equivalent to Q, that is P and Q are equivalent statements. Okay, and if in any case we find more than one connectives in a single statement, okay, then the order in which the connectives are given preference or precedence is this one. The ordering is done here from highest to lowest, that is first we will consider the negation or the not statement, then the and or the conjunction statement, then the or the disjunction statement, then the implication, and lastly the double implication or the equivalent statement. Okay. Now comes the concept behind the semantics. Okay. So semantics specifies how to put symbols of the language in correspondence with the real world. That is, it tells us that if a sentence is logically correct or logically meaningful or not. Okay. Say for example, we have this statement, the tree is walking. Think of it a little bit. A tree is walking. So the statement is looking syntactically okay, but it is logically not making any sense. Okay. So semantics thus specifies that this statement is logically incorrect, though syntactically correct. Okay. Okay. Let's now study some of the equivalent laws. The equivalent laws are essential to check the equivalency in between two statements. Okay. So these are some of the laws, like the idempotency law or the idempotent law, the associative law, the commutative law, the distributive law, the De Morgan's laws, the conditional elimination, and the biconditional elimination laws. Okay. So take a note of all these laws. This will be used in case of solving various questions in this chapter. Okay. As you can see here, the De Morgan's law, the distributive law, or the above three laws looks similar to what we have done in our set theory chapter. Okay. So you can relate those concepts with these reasoning concepts. Okay.